Kubernetes is an open source container management system. Kubernetes is sometimes described as the Linux of distributed systems, and this description makes sense. The large number of users and contributors in the Kubernetes community is comparable to the volume of Linux adopters in its early days. There are many different distributions of Linux: Ubuntu, Red Hat, Chromium OS. These different operating system distributions were created to fulfill different needs. Linux is used for Raspberry Pis and Android phones and enterprise workstations. These different use cases require different configurations of an operating system. Similarly, there are different distributions of Kubernetes because there are different types of distributed systems. The internal infrastructure of a cloud provider might use one type of Kubernetes to serve the users that are running application containers across their cloud, but a network of smart security cameras might be networked together with a totally different distribution of Kubernetes. And imagine a car. If you had a car that was running Kubernetes, you have a distributed system within the car, potentially, and the networking requirements, the application requirements for running a distributed system within a car might be completely unique. Brian Gracely and Michael Hausenblas join the show today to discuss Kubernetes distributions. They are both returning guests of the show, and their past episodes are in our archive. Brian and Michael work at Red Hat, which helps maintain the origin community distribution of Kubernetes, which Red Hat OpenShift runs on. OpenShift is a platform as a service that enterprises use to deploy and manage their applications. Full disclosure, Red Hat is a sponsor of Software Engineering Daily. Cloud computing can get expensive. If you're spending too much money on your cloud infrastructure, check out Do-It International. Do-It International helps startups optimize the costs of their workloads across Google Cloud and AWS, so that the startups can spend more time building their new software and less time reducing their cost. Do-It International helps clients optimize their costs. And if your cloud bill is over $10,000 per month, you can get a free cost optimization assessment by going to doit-intl.com/sedaily. That's doit-intl.com/sedaily. This assessment will show you how you can save money on your cloud. And Do It International is offering it to our listeners for free. They normally charge $5,000 for this assessment, but Do It International is offering it free to listeners of the show with more than $10,000 in monthly spend. And if you don't know whether or not you're spending $10,000, if your company is that big, there's a good chance you're spending $10,000. So maybe go ask somebody else in the finance department. Do It International is a company that's made up of experts in cloud engineering and optimization. They can help you run your infrastructure more efficiently by helping you use commitments, spot instances, right sizing, and unique purchasing techniques. This to me sounds extremely domain specific, so it makes sense to me from that perspective to hire a team of people who can help you figure out how to implement these techniques. Do It International can help you write more efficient code. They can help you build more efficient infrastructure. They also have their own custom software that they've written, which is a complete cost optimization platform for Google Cloud, and that's available at reoptimize.io as a free service if you want to check out what Do It International is capable of building. Do It International are experts in cloud cost optimization, and if you're spending more than $10,000, you can get a free assessment by going to doit-intl.com/sedaily and see how much money you can save on your cloud deployment. Brian Gracely, you are the Director of Product Strategy at Red Hat, and you are the host of PodCTL and Cloudcast, which are a couple of my favorite podcasts in the Kubernetes and cloud space. And Michael Hausenblas, you are a developer advocate at Red Hat on the OpenShift team. Guys, welcome to Software Engineering Daily.
Thanks a lot, Jeff, for having us.
Hey, Jeff, thanks for having us.
Yeah, so today we're going to talk about Kubernetes distributions and some other related topics. I also want to get your pulse on various goings on in the Kubernetes world and kind of how it's making its way into various enterprises and startups and whatnot. But starting with the topic of distributions, because this is something we haven't discussed very much on the show, Kubernetes is an open source project. I can pull down the community supported version from GitHub and run it, but many people who use Kubernetes are not using that exact community supported version. There's actually a range of different distributions. What is a Kubernetes distribution, and why do people use various Kubernetes distributions?
I think the simplest thing is people are used to the concept of an open source project, whether it's, Linux or some other thing that they're used to. And in some instances, pulling down bits from the open source community from the project makes perfect sense. It's a small enough thing, it's a tool, whatever it might be, and pulling it down, reading the docs is fine. I think when you get into something like Kubernetes, and the reason we're seeing the rise of Kubernetes distributions and even, Kubernetes managed services is that, Kubernetes is ultimately a building block of a much bigger platform. And the other things that are typically needed in order to get that platform up and running, everything from, networking and storage and logging and monitoring and how you tie in your build system and lots of other aspects, are lending more and more people to say, well, given how fast Kubernetes is being developed, it's got new releases every quarter and all these other things that you typically have to do to make Kubernetes work beyond just the upstream project. A lot of people are saying, I might like to leave this to others who do this all the time, whether it's a software distribution or managed service, and focus more on, building applications and doing things that are going to be, adding distinct value to my business.
There's been a history of different Linux distributions. So in the Linux era, there are a variety of Linux distributions. I guess that continues to today. For some historical context, Michael, maybe you could refresh us on why different Linux distributions came into being?
Right. In the same sense, in the same reason that we've seen the Linux distributions establishing themselves and adding tremendous value to what people are doing out there, focusing on the business bits and not on the infrastructure bits. The same thing is happening in Kubernetes now. So we're with Linux around 2000, 2005 or whatever. So at the end of the day, when you said initially, using the upstream core bits themselves, that's not exactly true. They can either run their own and build their own Kubernetes distribution, or pick one of the, I think over 30 certified Kubernetes distributions that are out there already. So at the end of the day, it's not the case that you can just simply use Kubernetes core. There are a couple of things that you need to decide. And if you do that, if you, for example, say, I'm going to use this product for networking and so on and so forth, then you are building your own distribution, right? You're rolling your own Kubernetes distribution. And you have to ask yourself, is that something that you want to do or should be doing, or focus on your core business? And the parallels are really pretty significant. I think that the main point really is to remind people we are still in the early days. Think back of where you were in 2000, 2005. Did you roll your own Linux distribution? Did you have a look at RHEL or Ubuntu or whatever? And yeah, that's pretty much it. That's where we are.
I was on Windows back then. So actually, I don't even think I think I was on Mac. I was on my dad's Mac back then.
Nobody's perfect. That's cool.
Nobody's perfect. Exactly. So what gets affected in these different Kubernetes distributions? How does the software vary in different Kubernetes distributions? What varies?
We're finding quite a bit varies from one to the other. And I think before we sort of dive into that, or before we, get into, are any of these distributions a fork, which is, kind of a lightning rod term in the open source community, I think it's important to sort of step back and say, what do I get if I just grab the upstream bits, from the project, and what am I actually capable of doing with just those bits? So the thing to understand is, Kubernetes is a distributed system. What you get from the upstream bits is basically, you get the control plane to a certain extent, which is what they call the masters etcd, basically the part of the system that says, what do you want to deploy? How do you want to deploy containers? And pragmatically, how do you want them to run? You also get some capabilities that are going to run on the hosts that keep track of, what the host is capable of, what hardware does it have in there, CPU, memory, those types of things that reports back to this central control plane system. And then there's some pluggability that comes with those bits in terms of, I could plug in a network system, I could plug in a storage system. But beyond that, that's sort of it, right? That's the bare bones things that you get with Kubernetes, the ability to say, I'd like to spin up some containers on these nodes. But beyond that, again, there are so many things that people need in order to make it work. So just at a really basic level, in order to make Kubernetes work or to make containers work, you need a container registry. Container registry doesn't come by default with Kubernetes. So almost every distribution that's out there is providing some way of either providing you a container registry or attaching a container registry. It provides pluggability for things like networks, SDN type of network, overlay networks, different ways to do networking, but it doesn't provide that by default. It doesn't provide you storage systems. So if you want to have distributed storage for your system. So, you start kind of going through this checklist of things that you need to run in production. And most of that's not provided by default in Kubernetes. There's ways to plug into it. And so those are a lot of times some of the basic things that are different between distribution A and distribution B.
Yeah, what Brian said, 100%, absolutely agree with that. There's just one thing to make sure that people understand. Although all these things are not shipped by default, luckily we're now in a position, which is pretty much true for the entire space, that we now have standards that cover all these pluggable parts, right? We have a CNI, the container networking interface for the networking bits. We have CSI for storage. We have CRI, the runtime interface, and so on. So we have standards for all of that, making sure that all these plugins are interoperable and that it's, rather easy to, yank out the one and put in another. And that's also the part of the responsibility of the person or the organization putting together the distribution, to being aware of these standards and adhere to these standards and make sure that everything, is fine.
Talk more about those interfaces, because I've heard about these and I haven't gone too deeply into them. We did one show on the container networking interface. What is there to the definition of an interface, like the container networking interface or the CRIO? I think is another one of these standards. What's the process of developing one of these standards, and what purpose do they serve?
Right. So you can think of it a bit like initially, to get stuff out, Google and also ourselves, Red Hat, we essentially said, okay, let's not upfront standardize things. Let's just reuse, for example, Docker as the runtime and so on and so forth. Let's hard code things in there, which is great to get things up and running. But if you're thinking about extensibility, and I recently gave an entire talk about extensibility alone that's nicely covered there, then you need to have a standard interface. How do I actually, replace the default container runtime, for example, with something else? And so over time, and first, I believe it was first the CNI, the network bits, essentially, rather than hard coding, having, if this environment or this plugin, then do this, rather than hard coding that in the source code, you essentially have an interface where you have a contract between Kubernetes, the component there, it could be kubelet or whatever, and the actual plugin that delivers that functionality, networking, storage, and so on. For example, a gRPC-based interface that says, okay, the kubelet tells the runtime, hey, launch me a few containers, and then the plugin goes off and does whatever it needs to do to actually launch these containers. So the interface really is a specification, it's an API. Nowadays, as I said, typically very often gRPC based, a contract between Kubernetes components such as kubelet, API servers, and others, and the respective plugin that might be from anybody, from some third-party providers.
And how do the different distributions, how do they interact with the core upstream Kubernetes? Is that the term, by the way, if we're talking about the main community version of Kubernetes, is the term upstream? I guess maybe we could talk a little bit about the graph of different Kubernetes distributions, because Brian, you mentioned that fork is a term. I didn't know that. So maybe you could talk a little bit more about the map of different, open source repositories. Right.
Essentially, in a nutshell, and maybe, Brian, if you want to expand on that a bit, but in a nutshell, it's project versus product, right? Everything that is a project, it could be Kubernetes or OKD, as it is now called, or any other project that, where people come together, typically in GitHub, mailing lists, Slack, or whatever, and produce software, that is the upstream part. And then if you're a vendor or whatever, you're taking these bits, various upstream bits, and then put some offering around that. That could be, for example, a product like OCP, like the OpenShift cloud container platform, right?
Yeah, I think that's it. So I'll give you a couple of really basic things. So Red Hat people tend to call the open source projects upstream just because we think of things as there's the open source project, and then sort of in our business world sort of flows down into the things that become commercial products. Some people just call it the open source project. So upstream open source project, kind of one and the same. The CNCF, who governs the Kubernetes project, wanted to make sure that we were all sort of adhering to this idea that Kubernetes was going to be usable as a multi-cloud project, a multi-vendor project, and so forth. And so they created a set of tests that allow you to say, here's my distribution of Kubernetes. Here's the thing I would take to market. I want to run it against your set of tests that'll validate that we haven't changed anything, that we haven't done anything differently, that if somebody starts running containers over here and then wants to move it to a different environment, it'll work fine. And so that's where you hear the CNCF saying we have conformant or certified Kubernetes distributions. And so that's a good thing for the market. It sort of lets them know, oh, okay, if I'm using, vendor A, vendor B, service A or B, most of these things should all just work the way they are. And then I think the word fork, the reason people kind of get upset about forks is there's some folks in not just the Kubernetes community, but in any open source community, when you add bits to the open source project, to an upstream project, sometimes they'll say, well, that only comes from this specific vendor, and that's a fork. And the reality is, lots of vendors, lots of projects will add things to them. Fork is a very distinct thing in open source. It essentially says, we took a copy of that project and we being whoever that is, we are going to essentially run a parallel project to that original one. And we're going to kind of disconnect ourselves from that. And there's reasons why that happens. Sometimes it's political, sometimes there's technical. The Node community went through this a while ago. But in the case of Kubernetes, there aren't any Kubernetes forks. There isn't a split in the community in any way, shape, or form. So I think we try and be very careful not to use a word like fork just because it has certain very distinct implementations of what you're doing to the rest of the community. In the case of adding some additional features that are above and beyond what's just in the open source project, that typically is the first thing that you often see in a distribution is additional stuff that typically is intended to make it easier for a customer to use, more secure for a customer to use, maybe a unique user interface, whatever those things might be.
The conformance standards that the CNCF has put in place, as I understand, those are to give a kind of stamp of approval that the CNCF is saying to, for example, an enterprise. If an enterprise is shopping around for what kind of Kubernetes distribution they want to use, they can find one that has a stamp of approval by the CNCF, which will mean that there's going to not be much lock-in, or at least lock-in will be minimized to an extent that the CNCF can endorse it. Is that the right way of looking at the conformance standards?
Yeah, I think so. The CNCF doesn't want to be a gatekeeper. Actually, the way that they do their conformance is really very cool. In essence, they take the exact same tests that the community uses to build and validate builds of Kubernetes, and they go, here's the tools. So, you don't have to wait for a long process from the CNCF. You actually can do self-validation, self-conformance. You run through these tests. You send the results that come back to the CNCF. They publish them. So as a very basic starting point, if you're an enterprise and you're saying, we're thinking about Kubernetes and we don't want to just pull the bits ourselves, that's probably a great first starting point, is to go, is the thing that I'm looking at on the conformance test. We've seen 30 plus companies that are delivering that. So it's a really broad market that's available to you. And then you start looking at what else is important to us. Do they do things with lots of ways that we can do networking? Do they run on top of different clouds? How are they supported? What's the price point? All the other types of things that you consider from an enterprise perspective.
Now, you guys work at Red Hat, and Red Hat has OpenShift, and so we'll talk about some of the specific subjective decisions that you can make with OpenShift, or that you have made with your distribution. But let's first talk more broadly. When we have this big landscape of vendors that are producing different Kubernetes distributions, these different cloud providers, other kinds of companies that are just rolling their own distributions, what are the kinds of subjective decisions that they're making?
I think it depends a little bit about who's ultimately making the decision. And I say that not to kind of avoid your question, but we see the Kubernetes decision, because it's sort of a platform level decision, and it impacts developers because of the applications that are running, but it also impacts the people that operate the platform, or DevOps teams, tooling teams. A lot of times it depends on who's making the ultimate decision and kind of what problem they're trying to solve. So, for developer teams, a lot of times they're saying, we want to make sure that the platform will work with all the tools that we like to use for building our applications, which is, in a lot of cases, we just want to build containers. But in other cases for developers, they don't want to know anything about containers. They simply want to write code, push it into source repository, have it run through CI pipelines. And somewhere down the line, they want it to get onto a platform. And in that case, they would like to know that the platform will do things like builds. Will the platform build my code, put it into an application, put it into containers for me? That's a feature that's sort of above and beyond what Kubernetes does by default. So that may be a deciding characteristic. They may look at it and say, well, we're a Jenkins shop, but we have these other groups that run in our organization that run Circle CI or Bamboo or Team City or something. Are we going to be able to plug all those things into this Kubernetes environment, right? And in some cases, that's another decision point. Like, can my Kubernetes platform work with a bunch of different CI things? On the ops side of things, a lot of times it's, well, we have a lot of existing stuff that we need you to integrate with, whether it's like LDAP and Active Directory, or, we have this networking system that we use today. Maybe it's VMware's NSX SDN, or maybe we're okay with, Linux OVS or whatever it is. We need you to plug into that. We need you to plug into our NetApp and EMC storage environment, or, we want to use Splunk as our logging system. All of those types of considerations come into play, and different distributions and so forth support them, others don't. And again, it really comes down to who's making the decision. How much do we have to integrate with existing tools, or are we really working in more of a completely greenfield environment? We can do anything we want to.
Sponsoring today's podcast is Datadog, a cloud-scale monitoring and analytics platform. Datadog integrates with more than 200 technologies, including Cloud Foundry, Kubernetes, Docker, and Kafka, so you can get deep visibility into every layer of your applications and infrastructure, in the cloud, on premises, in containers, or wherever they run. With rich dashboards, machine learning-powered alerts, and distributed request tracing, Datadog helps teams resolve issues quickly and release new features faster. Start monitoring your dynamic cloud infrastructure today with a 14-day trial. Listeners of this podcast will also get a free t-shirt for trying Datadog. Go to softwareengineeringdaily.com/Datadog to get that free t-shirt and that 14-day free trial. That's softwareengineeringdaily.com/Datadog. When I think about Linux, is used in so many different domains, whether it's IoT or Android or as a node in a Kubernetes cluster. I do wonder sometimes, is that how we're going to think about Kubernetes in 5 or 10 years, where we're going to have all these domain-specific versions of Kubernetes that are good at managing particular types of distributed systems? Or maybe we're already seeing hints of that today. Michael, what do you think about that idea?
Right. So, question essentially being, where is Kubernetes heading? What's the overall timeline? And to answer that, I think it's worth to have a quick look back where we came from, right? And that is that the first 1 or 2 years, I remember back then I still used to work at Mesosphere, and it was the container orchestration wars, right? Nobody knew around 2015 or 16 maybe who will be the winner, right? Will it be Kubernetes? Will it be Mesos Marathon? Will it be Docker Swarm or whatever? And with essentially end of 2017, beginning of 2018, these container wars, container orchestration wars are over. The Kubernetes ecosystem has clearly won and has established itself as the dominant player here, in the same way that Linux runs on most of the machines out there. Of course, there are other Unixy and other systems out there, but the majority is using Linux. So with that said, if you're thinking about, now we are mainstream, right? Majority of people are either looking at Kubernetes or using it in production already. Then the question really is, where is Kubernetes not a great fit? let me put it that way, right? Think about application areas like edge computing. Maybe it doesn't really make a lot of sense to, in an extreme case, run a Kubernetes cluster on a 3 Raspberry Pi unit somewhere, right? Maybe these are areas where Kubernetes never will be deployed. However, I do believe that going forward, there will be very, very few systems that are not either directly running Kubernetes, or it might fade away. It might be, in the background, so people don't even notice, but it will be pretty much everywhere, wherever it makes sense.
What do you think, Brian?
Here's the way we think about it sometimes at an even simpler level is, Linux became, really ubiquitous and all over the place. It's, it's in every public cloud and it's in every private data center because it was great at managing the resources of like one computer. It does a really good job of that. It's efficient, it's secure. And Kubernetes is ultimately kind of going to evolve to become the standard to manage the resources of lots of computers as if you want to manage it like it's, it's one pool of computers or something. So, as Michael said, we're still obviously in the earlier days of Kubernetes. It's becoming more mature. We're seeing more, people contribute to it. But ultimately, the goal of Kubernetes is not to look like lots of different systems. The goal is to say people are going to package their applications in containers. They're going to ask the system to say, give me certain capabilities, like, help me understand where other resources are. I want to do service discovery, or I'd like the system to, fail over in a certain way. And if you're an application developer and so forth, you shouldn't have to know about a lot of those things. And that's one of the areas that the Kubernetes community has been working really, really heavily on. Projects like Istio and some other stuff that's been coming along is there to make the system really powerful, but ultimately say, hey, developers, there's going to be a couple standard APIs that you'll write to. You're going to write your applications, and you won't have to necessarily know whether it's running on top of Azure or in your own data center or somewhere else. That's kind of where Kubernetes is going, is be very ubiquitous and everywhere, but don't make it unduly complicated for the developers that want to deploy applications.
I want to have this conversation in the context of platform as a service and OpenShift more specifically, because you guys both work on that. So when I was talking to Clayton recently, Clayton Coleman, who works on OpenShift as well, one thing we talked about is the fact that not everybody uses a platform as a service, or not every enterprise uses a platform as a service. Like me personally, I don't run an enterprise, so obviously I don't have an enterprise platform as a service. But personally, I use Heroku, I use Firebase, and I use as many other high-level tools as I possibly can. I do not want to go to a lower level than I need to be productive, because I just want to build an application. I have a high level view for my application and what kind of business function, or what kind of cool non-business, what kind of hobbyist function, what kind of to-do list or calendar app or whatever I want to build. It has nothing to do with wanting to manage cloud infrastructure. So is there still some conversation to be had with enterprises when you're trying to convince them it's not that you don't want to go with a cloud provider specifically, but having a layer of management above that is really important? Or has that kind of evangelism already been done to a necessary degree?
So it might be that Brian and I disagree on that one. Let's see. But I think at least in my point of view, it's like a PaaS by definition is opinionated, right? There's a very clear workflow. There's a very clear set of abstractions, be it, this is an app or whatever, whereas Kubernetes is not, right? And the beauty of Kubernetes really lies in its portability, right? And the promise doesn't matter if you start deploying stuff on premises and then move to Azure and then move to whatever, that will simply work. On the other hand, you have the passes and also functions, the service, serverless, that are naturally very opinionated, and people like that, right? I don't need to deal with pods and services and whatnot. I have my application, right? And then some magic happens, and that, is mapped to pods and deployments and services and so on and so forth. I don't think that there's a right and wrong. What I love about, in the case of our stuff, in case of OpenShift, is the fact that depending on the needs and the preferences of the customer, they can choose to either work on the PaaS level or on the Kubernetes level. So I'm not evangelizing either. I'm not saying you got to use the PaaS or you got to use Kubernetes level. It's up to you. Whatever, float your boat, whatever you prefer. And then, you have the choice.
Yeah, I don't think we disagree on this at all. a little bit is historical. Back in the day, in some early versions of OpenShift, back pre 2015, so a while ago, it very much was an opinionated system, like Michael said, right? It was very much intended to kind of mimic what Heroku tried to do, but just with an open source, kind of variation on it, where it was developers write code, they push the code. I don't want to know what's going on under the covers, and we will manage that for you. So kind of exactly what you mentioned, Jeff, is like, that's what some developers want. And at the time, that's kind of what the platform did. Obviously, we saw, as containers came along, and the downside of PaaS is the opinions are great up until they become a problem for you. And in some cases, what that was is it didn't support the language I wanted. It made me access file systems in a certain way, and that's not what I wanted to do. Boy, I'm having problems with my database performance. Like, how do I get access and see what's going on inside that system? I wish I could see that. So PaaSes are fine until they reach a certain point, or there's certain developer experiences that you want. But there are plenty of others who say, I want more control over which languages and frameworks I can use. I feel comfortable dealing with stuff like YAML and manifests and what I can do in a container file because it gives me consistency of how we do builds. The community seems to be moving towards this standard of Kubernetes. It would be great if I can pick and choose from different offerings instead of just one. And for us, what that ultimately meant was, in 2015, when we changed the platform out to be, driven by Kubernetes, we had to kind of tell the market, hey, we don't just do PaaS anymore. And markets have long histories and they kind of don't always remember when you make changes, but we don't care. I mean, we ultimately, if you want to see the underlying resources, you want to deal with containers directly, you want to do containers as a service, the platform does that. If you want to abstract what developers want to see and you just want to push code in more of a PaaS model, like that capability is still there in OpenShift. So, for us, we call it a container platform because that's the underlying abstract and constructs that you deal with. But it is another one of those things that when you say, what's the difference between a distribution and upstream? Those are sort of features that we've added to the platform or continued to maintain in the platform because there are very few times when developers want the exact same experience or any two customers want the exact same experience.
So that semantic difference between platform as a service and container platform, you might define as platform as a service is opinionated, opinions are mandatory to follow, whereas container platform is maybe you have opinions, but the opinions are optional or they can be swapped out for other opinions.
Yeah, I think that's fair without getting into lots of detail. But yeah, it's just as an example, and again, not a knock on anything else. I mean, like take Google App Engine or Heroku or any of those. I mean, early on, they allowed you like one or two languages. If you didn't use those languages, you didn't use the platform. We don't care which languages you use because containers they don't care. And so you can start with something as simple as that, like which language do I want to write in, as saying, hey, maybe that's a way of saying, do I have a PaaS or do I have a more composable, more flexible system?
So what does a developer or what does an enterprise want out of a higher level management set of tools? So obviously you have like this kind of one-clicky kind of experience where you can get different services, or you can, maybe have a marketplace of different services that you could pull in and make it easier to integrate with various tools and whatnot. Describe more what kinds of tooling people want out of that management layer, the container platform layer.
So I think the first thing to think of is that, as you get into larger companies or just companies that have, different requirements, different tends to be the key word there. So, if you go into a bank or forget the bank, if you go into any organization, there's always going to be this tension between part of the people that work in technology, their job is to be really efficient, take costs out of the system. And then there's always going to be groups whose job is go work on something new, go push the business into a new area, go make a new product, go do whatever you're doing. And just those two different tensions tend to drive different, needs and behavior. So let me give you a simple example. If let's say I'm a bank and I go, okay, I have a bunch of legacy systems and we've been told to take 20% of cost out of those systems. we're seeing customers on that part of a bank who go, oh, well, I could take existing applications. Today, maybe they run in VMs or they just run bare metal on Linux. We could containerize those. We could make the packaging around those consistent. The conversation that we have is consistent between the people that work on those applications, the people that package that, and then putting it into a system that is highly automated. And I can take cost out of that system. In that case, they just want to deal with the raw abstract of containers, being able to package them consistently and then run them in a highly automated Kubernetes OpenShift environment, right? There is no real sort of quote unquote developer experience they want. They just want something that says, oh, I could take some cost out of the system. It'll be cheaper to run them as containers than they did VMs. The flip side is people go, oh, I'm in, let's say, banking, and we want to build a Venmo-like system. We want to build a digital payment type of system. We want to optimize it for mobile. We want to be able to push updates out every 2 or 3 times a day or once a week, whatever it is. In that case, we're seeing people who go, my developers may want to know about containers. They may not want to know about containers. This is the build system we're going to use. Allow me to use any of those things because I'm going to bring in everything from a 20-year-old developer to a 30-year-old developer to a 40-year-old developer. Some of them are going to work on front end. Some are going to work on back end. And in that case, they may want everything from a self-service catalog that has a whole bunch of things pre-built for them that they can just click and pull down a database, click and pull down a runtime or a framework. In other cases, I've got some folks who are just going to write Spring Boot applications. They just want to write code. They're going to live in their IDE. They're just going to push it to the platform. I don't want to know anything about containers. And you start taking all these different needs and inputs just for the people that are trying to build the new app to go fast. And you go, I can't have one system to solve all those problems, right? There are 6 opinions about what they want to do, and they're all totally valid. And so for us as a platform company, we have to go, I have to integrate with a bunch of IDEs. I have to integrate with CI systems. I want to be able to provide a great service catalog so that it's easy if they want to just pull things. But all of those are slightly different and they're all totally valid. So having to be able to support all those types of inputs, those ways that people want to do stuff, that's really how platforms have evolved beyond the 12-factor only things that happened in PaaS systems.
Michael, what else are you seeing when you're having these conversations with companies that are adopting Kubernetes in various forms and they want some kind of assistance in having that? They don't just want to be deploying raw Kubernetes infrastructure.
It's important to distinguish between to who am I talking to. There's a huge difference between a 20-person startup in London versus a multinational 5,000 people organization that, has different, very, very different requirements and focus areas. So whereas a startup might, more be interested in agility and velocity, right? We want to have something that is maybe login might not be that big of an issue, but something that allows us to iterate quickly, to get a new version out very, very quickly and so on. Versus the established players out there that have a lot of legacy or already deployed infrastructure, nicer term for that, who worry about things like separation of concerns. We have a dedicated team of 5 people who, do the infrastructure bits. They are the infrastructure administrators setting up a OpenShift or Kubernetes cluster. They are, upgrading this. They are managing the storage. They are providing the namespaces or projects, as we call them in OpenShift, and so on and so forth. So they, and they have their developers, and these developers focus on, surprise, surprise, writing code, right? These kind of customers do not want their developers to screw around with, any sort of infrastructure related things. So it really depends on who am I talking to. And there, as I mentioned, a few things like the separation of concerns, security policy questions, who gets to see which kind of data or access to certain applications and so on. So all these things for bigger, more established customers, and for smaller, typically startups, it's mainly around velocity, ease of use and velocity.
To come back to the topic of distributions, so you have a specific distribution for OpenShift. So this allows OpenShift to integrate with Kubernetes. It's a specific Kubernetes distribution. So if we're talking about the process of architecting a Kubernetes distribution, let's talk about OpenShift as an example of that. So if I wanted to create a distribution of Kubernetes to integrate with a higher level management platform, what are the layers of abstraction that I need to be interacting with, and what's the interface between OpenShift and Kubernetes?
Yeah, we always like to tell people there is no separation between OpenShift and Kubernetes. Kubernetes is, in essence, the orchestration engine that runs OpenShift. So the way to think about OpenShift is we deliver the operating system, so either RHEL or Red Hat Core OS as the operating system. On top of that runs the Kubernetes orchestration system. And then beyond that, as we sort of mentioned early on in the call, you start saying, okay, I want to be able to provide our customers sort of all the defaults that'll be there, but pluggability if they don't love the default. So for us, that includes by default an SDN, software defined network system, as well as the CNI. So we provide a default multi-tenant SDN, but we also support like 8 or 9 different CNI plugins from different vendors. We provide OpenShift container network, OpenShift container storage. So essentially a cluster that runs natively on the container so that people have distributed storage within the platform. We ship a Elasticsearch, FluentD, and Kibana stack to be able to manage logging. So all the logging by default for containers as they come up goes into FluentD. We use Elasticsearch and Kibana to be able to sort through that and view it and so forth. We ship Prometheus by default for monitoring. So we include that as the default for monitoring. It integrates with tools like Grafana to be able to build dashboards and so forth. And then on top of that, we provide sort of a developer-specific user interface that allows them to see their projects. It allows them to do grouping and collaboration within that. We provide a service catalog that includes not only a bunch of content that Red Hat provides, so runtimes and languages and stuff, but it allows third-party tools to be plugged into that. So third-party ISV applications that have been containerized can be in that. So there's a bunch of things that we sort of look at and say, you need all these things by default to run your application. Kubernetes is just one part of that. But ultimately, they're all built around the premise of saying, I want to containerize my application and I want it to run using Kubernetes as the scheduler and orchestrator. And then there's just all these other things you need to make sure it's secure and monitored and highly available and stuff like that.
Right. If I might want to pile on one thing. So Brian mentioned a number of super useful bits like, Prometheus for monitoring, elk stack, logging, and so on and so forth. There's one part which going forward will be, I think, very, very important for not only for us, for the entire ecosystem. And that is the entire topic of application lifecycle management. So, it's one thing to use, let's say, a Helm chart to easily deploy whatever you want, Cassandra, Kafka, whatever on top of Kubernetes. But what about upgrades? What about data store specific things like backups or rebalancing or whatever? So what you're really looking at is a life cycle management. And that is something that we're yet another part where we innovated with the operators, which originally stems from Core OS, which is now pretty central and going forward even more important to how we actually cover the entire life cycle of an application that runs on top of Kubernetes / OpenShift.
Can you go into that in more detail? What do you mean by that, the application lifecycle?
Right. So if you look at, let's take any kind of off-the-shelf or whatever kind of software, it doesn't really matter if it's, a bespoke system or off-the-shelf. You, as an administrator, for example, namespace administrator, infrastructure administrator, you're installing this software, right? Now a new version comes up, or there are patches, or if there are some stateful components like Kafka has and Cassandra has and a lot of data store obviously have, or all of the data stores obviously have, then you need to, up to now, you needed to, after you've installed that, you somehow needed a process that might be manual. You would SSH into a pod, or you would use Ansible or whatever to somehow deal with these things, upgrades, rebalancing, backups, and anything, whatever it is specific to the actual software that you're deploying there. And that is now taken care of by what we call operators, which are essentially two things. On the one hand, or three things really, two technical things and one process. So two things from a technical side. The one bit is around so-called custom resources. So extending the core resources that Kubernetes knows about, custom types, and this custom type reflect whatever that piece of software really is. And then controllers. And these controllers, that is the core principle of how Kubernetes works. All of Kubernetes really is just a bunch of controllers, right? They look out what is out there going on. They compare that with what the user declaratively says should be the case, and then trying to make the one look like the other, like to converge this state. So you need this custom resource that represents your software, and you need that controller that knows how to deal with this custom resource. And then you have an operator, right? And the third bit I mentioned earlier on is the process. That's essentially a collection of good practices, how to go about, how to build these CRDs and controllers.
Yeah, I mean, ultimately, these systems, the design of these systems, where they're going is to say, look, you want the service that's going to be available to you. It could be a database as a service, a queue as a service, and you don't really want to have to maintain how frequently it gets updated or gets patched on the back end and so forth. And that's ultimately what these operators, this operator framework and lifecycle is doing. Is it's saying, if you're going to have a platform, you're going to manage it, it's going to run somewhere, build a bunch of automation, or actually take advantage of the fact that this new tooling, this automation framework, this operator framework is going to do that for you and take care of updates, patching, maintenance on a day two basis. So again, you're just focused on build applications, deploy them. The platform will take care of maintaining itself and so forth.
Data holds an incredible amount of value, but extracting value from data is difficult, especially for non-technical, non-analyst users. As software builders, you have a unique opportunity to unlock the value of data to users through your product or service. Jaspersoft offers embeddable reports, dashboards, and data visualizations that developers love. Give users intuitive access to data in the ideal place for them to take action within your application. To check out Jaspersoft, go to softwareengineeringdaily.com/Jaspersoft and find out how easy it is to embed reporting and analytics into your application. Jaspersoft is great for admin dashboards or for helping your customers make data-driven decisions within your product, because it's not just your company that wants analytics, it's also your customers that want analytics. Jaspersoft is made by Tibco, the software company with 2 decades of experience in analytics and event processing. In a recent episode of Software Engineering Daily, we discussed the past, present, and future of Tibco, as well as the development of Jaspersoft. In the meantime, check out Jaspersoft for yourself at softwareengineeringdaily.com/Jaspersoft. Thanks to Jaspersoft for being a sponsor of Software Engineering Daily. I want to talk a little bit about the future and particularly the topic of strategy, because Brian, I know you're the director of strategy, and it's kind of funny because as a podcaster, I get this 10,000 foot view of a bunch of different companies and talking to different people, but I don't spend any time at these companies, or I spend very little time at these companies. I certainly don't get an intimate view of what's going on at these companies. And I do wonder what it's like to be both an external commentator from the podcaster point of view, because you have to kind of empathize with other people at other companies and talk to them kind of in the same way that I'm doing right now, but you also have that intimate sense of what's going on within Red Hat, and specifically the business decisions, the strategic decisions. What kind of strategic formulations have you had to make in recent history, or describe? Maybe you could describe your role as director of strategy.
Yeah, so Red Hat is a little bit unique in the industry. So obviously, we've worked at different companies. In some cases, they did proprietary software. The hardest thing in technology, because it moves so fast, sentiment and trends move really fast, is trying to predict the future. One of the nice things about Red Hat is that we don't spend a lot of time trying to predict the future. What we try and do is we try and influence, where certain early trends are going. And that's kind of why we get so involved with open source projects. So, we weren't sitting there in 2015 as an example. We weren't sitting there saying, well, maybe Kubernetes will win, maybe Mesosphere will win, maybe Docker Swarm or something else will win. We basically said the only way we're going to figure this out is to be heavily involved in those communities. And so, you do have to pick something. In our case, it was Google came to us and said, we're going to, heavily get behind this system. We're going to make it open source. And so that was sort of a signal to us that said, well, somebody who has a lot of experience in this space, somebody who's done this in production, kind of has the DNA, is going to get behind this. They're looking for somebody who can help them navigate open source communities. We know how to do that. That's a strength we have. And if you can apply certain models that work that's always for us a starting point for strategy is, go be involved with the project, go be involved with the Docker project, even though your company's not named Docker, right? Go learn what goes on in Kubernetes, in containers. And then the other part of it is, it's really hard to be any good at strategy or even execution if you're not really close to companies that are dealing with it. So we spend a lot of time, I spend a lot of time, Michael spends a ton of time just out talking to people. And it's not selling to people all the time. It's not saying, hey, why aren't you buying this thing that we sell? It's saying, what are you trying to do? What problems do you have? What do you dislike about the thing that we have out there today? Well, how can we make it better? And so you're always kind of balancing this. How do we get involved with something a few years early? Try and be involved so that the community will grow and everybody can benefit from it. And then doing day-to-day stuff of just talking to customers, happy customers, upset customers, people that could care less about their product, but want to tell you what they're working on. You go talk to a bank, go talk to a hospital, go talk to a startup. And you got to find that's the balance that you're always trying to find, is like short-term validation of the stuff that you're working on, and then long-term models that can be successful, open source models, projects that lots of people want to get involved with, certain starting companies that are going to help contribute to the funds and engineering to make it successful.
I actually wanted to add something to what Brian just said in terms of talking to customers. The biggest part there, of course, I'm evangelizing, I'm talking about the newest features here and there, and people ask me about what is the newest trend and what about service meshes and serverless and this and that. But the really interesting bit for me is listening. And that's, for someone like myself who really likes to talk, it's really hard, right? to actively listen, to understand what the problems are. And it's not really my job to immediately come up with a solution to say like, oh yeah, here's a workaround or whatever. Sure, that's sometimes the case. But more importantly, I give that feedback back to product management, engineering, socialize that, saying, hey, I've heard this complaint like 4 or 5 times now. We should do something about that. This kind of very, very carefully and actively listening to what people say out there without trying to interpret too much, just to capture it and transport that back, feed that back into the company.
Well, what you just said there reminds me of another thing I talked about with Clayton, where there are these questions that are kind of easy for somebody like me, like a podcaster, a media person, to latch on to, like, what's going on with Istio? Is it going to be selected as the service mesh du jour? Or, like, when is a serverless platform going to be rolled into Kubernetes? And it's like, these questions are probably not the real questions that people who are actually buying Kubernetes care about. Things like, maybe they care about them, or maybe they will care about them eventually, but sounded like things like getting networking working better, or like making etcd a little bit faster. Those are a little bit higher order bits.
Yes, so there are things where it's all about saying, look, I think you need to forget about how you did stuff in the past, and this is the way it is done in Kubernetes. So unlearning things, but there are also things where we can only say, for now, like in the networking space, you have network policies and you have the up and coming service meshes like Istio and many others there. And keep an eye on that, try out this. But really what is interesting are the pain points, right? Or understanding what do people want to achieve, right? And these are the things that you I think suggested as well, right? These pain points, I want to do X. And then the question is just, is it kind of like just trying to extend a pattern that people used to do in an old environment, or is it something that is currently not yet covered?
Yeah, I think it comes from perspective. I'll give you an example of this. So, we were very fortunate that when Google decided that they were going to open source Kubernetes, we were one of the first companies that they called and said, hey, we'd like your support in the community. We'd like to work with you guys. We know you do some container stuff, but this would be a big leap. The viewpoint that Google had about how to use containers and, how do you build an application was going to be very, influenced by their experience of having, built applications inside of Google. So how they build maps or how they build Gmail or something. And we came to them with a very different perspective on things, having worked with a lot of, large enterprise customers. What some people might say, well, they're big and stodgy and so forth, but they do manage a good chunk of the economy and so forth. And there were things that we would have loved to put in, say, Kubernetes 1.0, things like role-based access control, or, how to access things beyond just blob storage or object storage. Like, how do I access NFS, or how do I, like you said, some sort of network thing. And there are going to be people that were like at Google who are going, no, that's not important. That's not how we do it. That's not important. But here we are, a couple of years later, and technologies like role-based access control are now core to other things, right? And we pushed them at the time. The community kind of said, no, not the right time for right now, or it's not really in our perspective or domain. And we just said, okay, we're going to keep pushing along on it. We're going to develop this stuff. We're going to kind of have it ready to go. And then a year or so ago, like last year, the community finally said, yeah, it's the right time for that, because more and more of them were like, oh, hey, we're going out to enterprise types of customers and they're asking for this stuff. And so let's add this, right? So it's not a matter of like, you have the right perspective or I have the wrong perspective or vice versa. It really is, you come with certain experience, and there's sometimes it's just the wrong time. Sometimes it's, gosh, I'm not hearing that from anybody. And then other times the world kind of opens up and you see different perspectives and things make sense. So it's the great thing about the Kubernetes community, in that you've got Red Hat and people like that who have a lot of enterprise experience. You've got people like, Google and Azure and AWS who are running these big global scale clouds and so forth. They've got a different perspective to bring. And you start mixing all those things together and you get a pretty robust system that can work in a lot of different places.
That is really cool. I like the idea of vastly different perspectives of Google, who has they have legacy infrastructure, of course, but not legacy in the same way as like a bank that's been around for 30 years. And
yeah, and it's not only hardware, right? It's many things. It's the monorepo. It's many things that I always tell people, well, you're not Google, and no one is Google other than Google itself, right? So don't try to adapt these kind of things. Try to get the good parts out of that, of what makes sense, declarative APIs and so on and so forth. But don't try to be Google in that sense, right?
Well, and a bank didn't start as a technology company. Today, they incidentally became a technology company if you're a large bank. But, I've talked to these challenger banks, some of these newer banks like Monzo that started in the last 5 years, and they're coming from a completely different perspective. And it's such a massive advantage to be able to start from the point of view of, I know I'm a technology company. Anyway, on that note, just to wrap things up, I'd like to get both of your perspectives on where we are in the adoption cycle, because there was a while ago I did a lot of shows from people in the, quote, DevOps community. I went to the DevOps Enterprise Summit. I talked to some people there. One thing I found interesting about that was, it is another problem with just being a podcaster, is if you just talk to people who are kind of the evangelists of the movement or the success stories of the movement, then it sounds like everything's working great, right? Like, yeah, we started having these DevOps meetings, and then we got, tests across all of our infrastructure, and then we're doing continuous delivery the following week, and everything's hunky-dory. When in actuality, it's like, that's not the pace at which things move. It's like, we don't even know how to test this giant blob of code. It's a complete black box, and we can't even get to continuous delivery if we don't have automated tests, and it's going really slowly. And we started this DevOps movement like 4 years ago, and it's still like 10% maybe code coverage or something like that. So it's hard to get a sense of what is actually going on. So maybe you guys could each give me your perspective on how rapidly large enterprises are adopting Kubernetes and what their pain points are in that adoption cycle.
So to me, it's like super important. And remember, I'm mainly upstream Kubernetes community guy and so on, that not only being allowed to, but really intentionally making mistakes. And by that, I don't mean making the same mistakes, right? But making new mistakes. And that's the big difference. If you keep making the same mistakes, well, probably there's something wrong with your methodology or with whatever you're trying to do. New mistakes, that is something that's interesting, right? New mistakes, by that I mean, new ways to fail, new ways, you haven't seen that constellation, that bug before. And a very simple analogy will probably help shedding some light on that. if you compare Zookeeper, which is, an interesting piece of software, versus etcd, there are still a couple of people out there and that rightfully believe that Zookeeper is superior. Why? Because they have seen it failing more often, right? They have seen it failing for way longer than they have seen etcd failing. So this is not a property of the software per se. It's just a matter of how long can you, use something and torture something, and you see it fail in different ways. In that sense, I think we are already in a place where we've seen a lot of components in Kubernetes failing, quite often. So we have a fairly high level of trust in things like etcd and the API server and things, the core bits. And then there are other things that are very new. For example, service meshes, right? Although we now have Istio 1.0, we haven't seen that many, long-term production deployments yet. We haven't seen it failing often and badly enough yet. So we are somewhere, and I'm bullish about that. I think we are already entering the mainstream, if not already in the mainstream, but there's still an awful lot to do in terms of the basics, in terms of teaching people how to do cloud native properly, how to do horizontal scaling, how to do failover, and so on and so forth. So entering mainstream or being already in the mainstream, and the next 2 or 3 years will be super exciting.
I'll throw a couple things on there. I agree with everything Michael said. Just from an actual deployment perspective, I think we're still in very early stages just in terms of education, people understanding how to build distributed applications, people learning how to manage distributed infrastructure and getting it frequently updated and so forth. We're on the order of like thousands of deployments for, number of customers that use Kubernetes for stuff and, in production. For a lot of them, the learning curve, the process of everything that you talked about, Jeff, kind of understanding CI pipelines. How do I test this code? Are we doing stuff that's DevOpsy? It usually takes somewhere between, 18 months, 24 months. Sometimes it takes a little longer if they fall down a few times. But the demand for this, whether it's just for knowledge or whether it's, we have 3 or 4 applications that we think really could take advantage of, container consistency packaging, Kubernetes scale. It may not be every application they have, but it's, a few is really high right now. We're busier than we've ever been. But yeah, I think it's maturing quickly, but we're still, if you had to point this out in one of those like crossing the chasm kind of maps, we're somewhere near the chasm still, whether you're on the left side of the chasm or the right side. We're definitely not in the mainstream, which is good because we're still seeing a lot of new technology getting added, but we are seeing the customers that do use this stuff, they do use it in production, are very happy, like they're seeing great results. So that's a good early sign. It's not something that got a lot of hype, sort of failed, and then it's trying to dig itself out of a hole of sort of broken promises.
All right, guys. Well, it's been really great talking, and I'm sure we'll have more conversations as we slowly cross the chasm. I appreciate you guys coming on the show in the past as well. Those have both been popular shows, so looking forward to more conversations in the future.
Thanks, Jeff. Really enjoyed it.
OpenShift is a Kubernetes platform from Red Hat. OpenShift takes the Kubernetes container orchestration system and adds features that let you build software more quickly. OpenShift includes service discovery, CI/CD, built-in monitoring and health management, and scalability. With OpenShift, you can avoid being locked into any of the particular large cloud providers. You can move your workloads easily between public and private cloud infrastructure, as well as your own on-prem hardware. OpenShift from Red Hat gives you Kubernetes without the complication: security, log management, container networking, configuration management. You can focus on your application instead of complex Kubernetes issues. OpenShift is open source technology built to enable everyone to launch their big ideas. Whether you're an engineer in a large enterprise or a developer getting your startup off the ground, you can check out OpenShift from Red Hat by going to softwareengineeringdaily.com/redhat. That's softwareengineeringdaily.com/redhat. I remember the earliest shows I did about Kubernetes and trying to understand its potential and what it was for, and I remember people saying that this is a platform for building platforms. So Kubernetes was not meant to be used from raw Kubernetes to have a platform as a service. It was meant as a lower level infrastructure piece to build platforms as a service on top of, which is why OpenShift came into manifestation. So you can check it out by going to softwareengineeringdaily.com/redhat and find out about OpenShift.
Wow.